Okay, here's a helper video to help you with the homework, derivatives chain rule. So there's two ways you can do these problems. You can use U-Substitution, or you can simply use Harold's first law of derivatives version 2.0. So I am going to do an example first with U-Substitution, then I'll do a couple of examples doing it kind of the fast way. So first of all, U-Substitution. I have this 2x minus 1 that I can change to a u. So wherever I have like a polynomial happening, I can change that polynomial to my u. And then I can take the derivative of that. So this would be, if I write it out, sorry, in more proper notation, it would be du dx. And that would be the derivative of 2x minus 1 would be 2. So if I've replaced 2x minus 1 with u, then I'm left with u cubed, okay, because this becomes a u, and I still have my cubed. So this would be dy du, as opposed to dy dx. And if I take the derivative of that, I get 3 times u squared. So I bring my exponent down front, and I subtract 1 from my exponent. Then to get the final derivative, so which would be to multiply these together, I would get 2 times 3u squared, which gives me 6u squared, but I'm going to replace the u back with the 2x minus 1. So notice how that takes up a lot of room. Okay, so I multiplied this times that, and then I replace my u back with what u was originally. So if we think about how Harold did it when we first discovered this in fourth period, and sorry, in third period you weren't there to see this amazing discovery, we actually were able to kind of shortcut the whole process. So to shortcut the whole process, instead of replacing the 4x plus 7 with u, I just kind of go with it. I just leave it where it is. So I'm going to bring my exponent down front. So my derivative is going to be, the exponent comes in front, 3. There is no number in front of the parentheses, so I don't have to worry about multiplying it by anything. Inside the parentheses stays the same. And I subtract 1 from my exponent. Now I need to multiply by the derivative of what's inside the parentheses, which is 4. And then I can simplify that. 3 times 4 is 12, 4x plus 7 squared. Okay, so that clearly is faster than doing the U-Substitution. The U-Substitution is helpful when you get into real complicated situations and you're starting to get lost. The U-Substitution is really handy. But on something simple like this, and actually all the rest of the problems in this worksheet, the U-Substitution actually kind of takes up a lot of space and time. So, excuse me, let me look at this one again. Without using U-Substitution, again, we would bring the 3 down in front, and then I keep my 2x minus 1, reduce the exponent by 1, and then times by the derivative of what's inside the parentheses. And then I could simplify that. 3 times 2 is 6. I keep what's inside my parentheses, and my exponent is a 2. Okay? So we could do the fast way on all of these, or you can use U-Substitution, whatever works for you. Okay, so one thing that I want to point out is you can also check this in Desmos. So I'm going to see if I can switch over. I wonder if this is going to work. Trying to switch over to my computer. No, it's not doing it. I was hoping that I could show you my computer screen, but it's not letting me switch over and showing my computer screen. So anyway, I wonder how I can do this. If I put my computer screen, I have no idea what I'm showing you right now. But anyway, if you go into Desmos, remember you can put in, you probably can't see this at all, so put it aside. So you can put in your original function here, and then on the third line, put in the derivative that you found, and the derivative that Desmos graphs for you should match what you found yourself. Okay, I have no idea if you just saw that, because I have no way of previewing this video while I'm making it. But anyway, you can check yourself by using Desmos. So I would recommend that every now and then you check one. All right, so let's go ahead and look at one with e to the x, okay, so a exponential function. And here, again, I could do U-substitution. I can change my little polynomial here, 3x plus 1, makes sense to me. The derivative, du dx, would be equal to just 3. So then if I've replaced this with u, I'm going to have e to the u. So that's my dy du. Oh, sorry, I haven't taken the derivative yet. What am I doing? I made that mistake up here. Sorry, I hadn't taken the derivative yet. This was just y equals. Eek! Sorry. All right, so back to here. This is just y equals e to the u. Now I can take the derivative, dy du. And for this one, when we have an exponential function, e to the x is just e to the x. So e to the u is just e to the u. Ah, crazy. All right, so then I'm going to multiply these together. So my derivative, going back to this notation, yeah, you know what? I'm thinking about my notation. I'm changing my mind. Sorry. I should have thought this out ahead of time, right? Sorry. Okay, I'm just going to call that u prime, and I'm just going to call this y prime. Okay, there's lots of ways we can do this notation. So dy du and du dx, or just u prime, y prime. Okay, so now I'm just going to multiply these back together. So it's going to be 3 times e to the u, and I'm going to substitute back in for my u, so I get 3 times e to the u was 3x plus 1. Okay, and again, you can put that in to Desmos. If you type in this, and then type in f prime of x, and then for this one, type in y equals, put this one in as y equals 3e to the 3x plus 1, you should see that the derivative and this one match up. Okay, so you can check it yourself. Okay, I also could have done this without U-substitution. I know e to the x, the derivative of e to the x is just e to the x. So I just keep this, there it is, and then I multiply by the derivative of the x, of what's in here, which was 3. Bam, that's it. All right, so you can do it the real quick way, or you can do it with U-substitution. And sorry, I changed my mind on my notation. All right, so these 5, 6, 7, and 8 are all similar. Okay, going to the back. The derivative of sine is cosine. So again, I could do U-substitution, but I think at this point, hopefully you're seeing that there's kind of a pattern going on here. So I'm just going to go ahead and go straight to the answer, because these are actually really simple. So the derivative of sine is cosine, and then I just keep whatever the angle is. But then I have to multiply by the derivative of what's in here, times 2. Now I'm going to rearrange this because it doesn't make sense to put the 2 here. We always put the coefficient in front. So I'm going to write 2 times cosine of 2x. All right, and then again, you could put this into your computer. Put in f of x, type in f prime of x, let Desmos show you the derivative, and then for this one, write y equals 2 cosine 2x. Put that in to Desmos, and you should see that the one that Desmos graphs for you and this one match each other. Okay, but here is the answer. Notice I'm not multiplying the 2 by what's inside the parentheses. This 2 comes out front. Okay? All right, so these 4 are pretty much the same, and then the natural log. The natural log, the derivative of the natural log is of x. The derivative of natural log of x is 1 over x. Okay, these are all in the formula packet as well, so you can look them up. So again, I'm going to do this shortcut way. So natural log of x, the derivative is 1 over x, but in this case, my x is 5x plus 4. You know what? I think actually I changed my mind. I'm going to do this one with U-substitution, just because I think this one's a little crazy. Okay, this one's actually a little bit more complicated. So I'm going to change this to natural log of u. So what's u? U is 5x plus 4. So the derivative of u is just 5. All right, so now I have y is equal to natural log of u. So what's the derivative of that? That would be 1 over u. Now I'm going to multiply those together. So f prime of x, the whole derivative, is 5 times 1 over u. I'm going to substitute back in for u, my 5x plus 4. And notice I did a little cleaning up as well. I did the 5 times 1 and just put that 5 on top. Okay, so here's my derivative. If you were to graph this, though, you would notice that this doesn't quite match the derivative, because this gives you more than what the derivative of this actually is. Okay, and the reason for that is that you cannot have this number be a negative. 5x plus 4 cannot be a negative, because if you think about logarithms, e to some exponent has to equal 5x plus 4. So you can't take e, which is a positive number, and change it to a negative number. You can't take e, which is a positive number, raise it to an exponent, and end up with a negative number. So 5x plus 4 cannot be negative. Okay, another thing that 5x plus 4 cannot equal, think about the derivative, 5x plus 4 cannot equal 0. So we need to put a little limiting factor on this. 5x plus 4 has to be greater than 0, and it cannot equal 0 because the denominator doesn't exist at 0. So we actually have to solve the inequality. 5x plus 4 has to be greater than 0. So I'm going to minus 4 and divide by 5. So the domain for this function is only when x is greater than negative 4/5. So we looked at this yesterday when we were putting this into Desmos and trying to discover the derivatives for natural log and for sine and cosine and for the exponential function. We discovered that the derivative that we were guessing didn't match exactly because we had to cut it off. So here's how we cut it off. We say what's in here can't be negative, and also it can't be 0. Okay? And so I say 5x plus 4 has to be greater than 0. Solve that. That gets me my domain. All right, same idea for the rest of these. Number 17 and 18 are cosine. We already went over the derivative for cosine, so you solve these the same way that you solved this one up here. Okay, so I hope that helped. Again, you do not have to do the U-substitution. If you just want to do Harold's first law, that is fine. In fact, it's a lot easier and faster once you get the hang of it to not do the U-substitution on these. But U-substitution is a very handy method for when things get more complicated. So it's good to practice U-substitution as well. All right, good luck. See you Friday.